So since we learned a lot of concepts, I wanted to go over a couple of miscellaneous topics which are important. So one thing that if you have noticed is I try to summarize my plots in English. So for example, all this, I was just trying to explain you concepts. But if you look at plots like this, if you remember yes, if you look at a plot like this, where we looked at the pair plots, right? So at the end of this plot, I always try to explain what my conclusions are or what my observations are. You can also call it conclusions or observations. Again, observations could be misinterpreted as data points. So these are my conclusions by looking at this plot. It's always important to write your conclusions in simple English that everybody can understand. Folks, please remember, as a data scientist or as a data analyst or even as a machine learning engineer, you do a lot of data analysis and you'll have to share your work with colleagues who may not be data scientists. And hence, it's always important to put your understanding, your conclusions, your interpretation in simple English that your managers, your colleagues, your non-technical peers from marketing, sales, all sorts of teams can easily understand. Remember, as important as doing data analysis, equally important is communicating your results. So if you cannot communicate your results clearly in easily understandable terms, then all your data analysis will never be actionable for the teams that you're doing this analysis for, or for the businesses that you want to improve. So I want to double down on this, that please, any data analysis that you do as assignments or in general, please, whenever there is a conclusion that you've understood, please write it in simple English with observations or conclusions tab just underneath it, because many people may not know what a pair plot is, but as soon as they read this, they know what they know the conclusion that yes, petal length and petal width are important, and it's easy to separate setters are not so easy to separate virginica and versicolor. And the moment you say I can write simple if else conditions, wow, that's terrific, right? So please, I repeat it, I emphasize it, I double emphasize this, please write conclusions of plots that you get by in simple English. Having said that, there is one problem that I often see, because I've run this class offline, and one of the things that people do is people forget the objective that they're solving, the problem that they're solving when they're doing exploratory data analysis. There might be 100 other findings in this data set which are not relevant to the problem we are solving. Always remember the objective. Our objective is to classify our flowers into setosa, versicolor, and virginica, right? So all your data analysis should be aligned with your objective of trying to separate them. Here I could do 100 things. I could do many things which have got nothing to do. For example, let me give you an example, right? So here in this plot, while I was trying to explain you concepts like histogram, bin width, etc. This was done just on setosa flowers. This analysis has got nothing to do with my objective of classifying. My objective is classification, right? So it has got nothing to do with my objective, but I still drew it so as to explain you the concept of what a histogram is, what a PDF is, what's a CDF, and things like that, right? But when you actually do it in the real world, this is only for teaching purposes. But when you do it in the real world, please perform your exploratory data analysis without losing sight of your objective. I hope I made myself very clear, because if you do some random analysis, that's not going to help address the problem or solve the problem you're trying to solve. Having said that, let's go and define a bunch of terms. We've done lots of analysis, but there are some terms associated with it. When you're looking at only one variable, let's assume I'm only looking at petal length and I've plotted histograms, box plots, violin plots, etc. Such an analysis where I'm taking one variable at a time and analyzing it. So all your PDFs, all your CDFs, right? All your box plots, right? All of your violin plots, etc. All of them are basically doing univariate analysis, to put it bluntly, right? Because we're taking one variable at a time and understanding what's happening there. The next concept is called bivariate analysis. Bivariate is nothing but your pair plots are actually doing bivariate, right? Your pair plots, your scatter plots, right? Because I'm looking at two variables at a time. Like for example, in some of the plots we saw petal length and petal width, right? In pair plots we saw all such combinations. So when you're looking at two variables and doing analysis, it's called bivariate analysis. Then the next thing is called multivariate analysis. Multivariate analysis is when you're looking at more than two variables. For example, if you recall, we saw the three-dimensional scatter plot, right? So that's an example of multivariate analysis. Of course, multivariate analysis is a very long and very large subject in itself. All your machine learning is basically multivariate analysis, if I have to put it simply for you. Because you have lots of variables. In our case, we have 4 variables. Any model that you build, we're going to leverage all these 4 features, your sepal length, sepal width, petal length, and petal width, to build a model. So your machine learning is nothing but it's a glorified multivariate analysis, if I have to put it that way.